Welcome to lecture 11.1. We are now looking at something called conic sections, and we're looking specifically at items called parabolas. Now, we have more than likely worked with parabolas if you took Math 103 or Math 135 before this, you've seen parabolas. This is a slightly different way of looking at parabolas, a little more intensive a way, I might say. So, if we're talking about conic sections, what exactly is that? Well, let's see if we're looking at the 3D graphing world. So normally we're only looking at 2D. But if we're looking at the 3D graphing world, if we have the XY plane, for example, we'll get items that are sort of in the 3D realm, right? So if we had something like a cone. And then what someone would look at is if we took a section of that cone, what items do we get? So if I took a section of this cone, one item I might get here for our conic section would be something that we would call an ellipse. Okay, that is one item we might get for a conic section. And then something here, if we took a conic section like this, and it just went right here, that's where we hit on our cone, that is something that we'd call the parabola, which is what we'll be looking at here. And then another item, if we took a section straight down between the two cones that are created, we'll get two sort of opposite facing items, and we call those the hyperbola. Okay, so these are just items we can get if we're sort of playing around with the 3D realm and a 2D item sort of put right through them. So what are some of the main things we have when we're looking at a parabola? Well, a parabola is a set of points in the XY plane, so in 2D, that are equidistant. What does equidistant mean? That means the same distance, equal as in same, so the same distance from a point F, so capital F here, called the focus. And let me go ahead and highlight that here. So we have this point F called the focus, and a fixed line L called the directrix. Okay, L called the directrix. Alright, so what is this again? So parabola is a set of points in the XY plane that are equidistant from the focus and the directrix. Okay, so the distance between here and here is the same along the entire line. What else do we know? Well, the vertex is halfway between the focus and the directrix. So more than likely you recall hearing the vertex in Math 135 or Math 103. That is a known term. Focus and directrix are new, but vertex we have seen before. It is the point in the very middle, either the minimum or maximum of a parabola. So the vertex is exactly halfway in between the focus and the directrix. And the axis of symmetry, that's something we've also heard in Math 103 or 135, is the line passing through the focus and the directrix. Sorry, the focus and the vertex, so passes through the focus and the vertex and is perfectly perpendicular to the directrix. So perpendicular meaning the two of them form a right angle. So those are the new things. We've seen vertex before and we've seen axis of symmetry before. So the two new terms in this class are focus and directrix. Let's look at some other things. So parabola with a vertical axis. Alright, so one thing to note before we move on is usually in Math 103 or Math 135, we were looking at equations for parabolas of y equals ax squared plus bx plus c. The ones we're going to be looking at here are, these values are 0. So b and c are equal to 0. That's the one we're going to be focusing on now. So if you'll notice here, that is true. We have our x squared value and our y value, but we don't have an x value, or x to the first power value. So if we have this equation where we have x squared equals to 4 times some number times our y variable, so one thing to note here real quick, p is a number, but y is a variable, so x and y would be our variables. Then we have a parabola with the following properties. Okay, so we have the vertex, which we have seen before, and for this specific type of graph, or specific parabola, because we don't have the b and c values right here, let me go ahead and highlight those, because we don't have these, our vertex is going to be centered at 0, 0. Please note, always denote your vertex with the capital V, and then the focus would be at 0, comma p. What is p? P is the value multiplied to the y variable times 4. Okay, so it's not the value right next to the y variable. It's 4 times that value next to the y value. What do I mean? So let's see, for example, if I had x squared equals 12y, p would not be equal to 12. Why not? Well, according to the formula, it needs to be 4 times some number. So we need to rewrite this as x squared equals 4 times something. Well, 4 times what would give me that original 12? 3. So this would be 4 times 3 times y. And now that fits the correct format, so our p-value would be, in this case, the 3. Okay, so be careful with that. It's not the value right next to y. And then once again, we would label that with the capital F. Please use the capital F. And as always, it's going to be in a coordinate point set. So you need to write it as a coordinate pair and then use the capital F. And now the directrix. Okay, the directrix is not a point, so you're not going to write it in coordinate form. It's going to be written as a line, and so please make sure to label your line accordingly. That is something I will be grading for. The directrix is going to be y equals the opposite of p. So whatever p is, you're going to take the opposite. If it's a 3, you'll take the opposite, so it'll be negative 3. If it's a negative 3, you'll take the opposite, so it will become a positive 3. So let's go back to the example we had just a second ago. We wrote this into 4 times 3 times y. So in this case, what would the equation of our line be? It would be y equals the opposite of p. So in this case, p was 3. So the opposite of p would be negative 3. And we would go ahead and label that on our graph. So once again, these are items that I will be looking for on the graph for grading. And please make sure they are labeled correctly. That is definitely something I'll be grading. Okay, so the parabola opens upward if our p-value is greater than 0, or positive, or downwards if our p-value is less than 0, or negative. Okay, so once again, opening up means it's facing this way, and opening down is this way. Or another way of thinking it, opening up is a happy face, and opening down is a sad face. Okay, let's take a look at some of our problems. Example 1. Find an equation for the parabola with a vertex at 0, 0 and a focus of 0, 1. Sketch the graph and label the key information. Alrighty, so what are we given here? We're given 2 pieces of information, and as usual, what you are given, you should be able to find the answer based on what you're given. What are we given? Well, we are given the vertex at 0, 0, and it has a focus of 0, 1. Okay, let's take a look again at what vertex and focus were. The vertex, focusing at 0, 0, that means that I can be using one of these equations. And then the focus, f0p, okay, the value here will be the p-value in my equation. So let's go ahead and look at this. We know that because of our vertex at 0, 0, we can use the equation x squared equals 4py. So we can go ahead and use that. That's the generic equation for our vertex. And then what else do we know? Well, we said we know what p is. P is the value here on the focus, so p equals 1. Let's go ahead and plug that in. X squared equals 4 times 1 times y. And then we get the equation x squared equals 4y. Alright, so this is the equation of our parabola. Let's go ahead and box that off. Now, what else do we need for graphing? We need the key information, and the key information is the vertex, which we know. Let me go ahead and write that down. So vertex, actually we can just go ahead and do v. 0, 0 is the vertex. The focus f is 0, 1, and now we need the directrix. I'll just go ahead and label it with a capital D. The directrix is, remember, it needs to be an equation because it's a line. It's y equals the opposite of our p-value. And our p-value was a positive 1. So what's the opposite of that? A negative 1. Okay, so these are our 3 important values, but one thing to note, please be careful here. I want you to label 2 other points on your parabola. So in total, there'll be 5 things you're looking for. So let's find the 2 other points. Our xy. I'll go ahead and pick just 2 random points. Let's go with 2 and negative 2. If x is 2, then what will y be? Well, we go ahead and plug it into our equation. We get x is 2. That's going to be 4. Divide both sides by 4. We'll get y is equal to 1. Do the same thing with the negative 2 for x. Plug it into our equation here. We'll get the negative 2 squared. Divide both sides by 4, and we'll get y is equal to 1 again. Alright, so now we have all the information we need. We got the 3 main guys here, and then our 2 extra points that, once again, will be required for when you're graphing these. So let's go ahead and graph. I will use green. So we have our vertex here at 0, 0. What else do we have? We have a focus of 0, 1. So let me go ahead and label this. You know, since we're using such small values, I'll go ahead and label our tick marks a little larger than you would usually see. Once again, if you're given a blank graph, it is up to you to decide the labeling. Just make sure you indicate exactly how it should be labeled or scaled. Alrighty, so there we go. What else do we have? Well, we have our focus of 0, 1. Now, one thing to note, our focus is not actually on our graph. And then our directrix of negative 1. And let's go ahead and draw in that line. Our arrowheads, oops, that's going a little off. Let me fix that up a little bit. Okay. And labeling that, we need to label everything. So we have y equals negative 1. And then our 2 points that are actually on a parabola. So 2, 1. And 2, or negative 2, 1. So negative 2, 1, and 2, 1. And once again, with a parabola, there should be some curves. So please note that. You might have noticed on your last exam, you may have been graded for it. Please make sure that there is a curve going on. Okay? It doesn't need to be the perfectest curve in the world, but there should be some curve. It shouldn't be angular, okay? So you shouldn't be drawing a straight line between those. That blue is a no. The green is what you're looking for. Just a nice curve. Okay, so there we have it. The first one we've done, example 1. Now let's take a look at example 2. Find the focus and the directrix of the parabola y equals negative 2x squared. Sketch the graph. Label the key information. So once again, let's go over this. What is the key information we're looking for in a parabola? Focus, directrix, vertex, and 2 points. What are we given? Well, we're given y equals negative 2x squared, and we're told to find the focus and the directrix. What about the vertex? What's the vertex? Well, let's see. Our parabola is given in this format. And the format of a parabola that looks like x squared equals 4py will have a vertex of 0, 0. Does this equation match that format? Well, let's see if we can get it into the right format. So let's go ahead and get x by itself. Means we're going to divide both sides by negative 2. And at the same time, I'm going to switch both sides. X squared is going to equal, and we have negative half y. So notice I just flipped both sides of the equation. So is that in the correct format? And the answer is yes. So we also know I have a parabola with a vertex of 0, 0. So let me go ahead and write down that information. So capital V is 0, 0. And now we need to find our focus and our directrix, and then 2 other points. Okay. Well, as usual, in the generic equation, we want 4py. So we want something times p equal to y. How do I find that? Well, we're going to be a little sneaky here. We're going to go finding p. What we know is this value here somehow has 4 times a number to equal that. How do we find that number? Well, let's just create an algebraic equation. We'll say 4p equals negative half. Once again, why are we doing this? We're trying to figure out what p is. And we know that somewhere in here with the half, that's some number 4 times p. We're trying to find that p number. Alright, so to get p by itself, we'll go ahead and multiply both sides by a 4th. Not the only way to do it, but I usually like working with fractions. That cancels, and then we are left with p equals, oops, wrong color, let me change that. P equals negative 1/8. Okay, so I didn't give myself a lot of room. But this is going to equal, so x squared is going to equal 4 times, squishing this in here, negative 1/8 y. So that is the equation, that is the equation of our parabola written in the right format, because I can see our p-value. And our p-value, as we have discovered, is negative 1/8. So let's go ahead and fill in our focus and directrix. So focus is going to be 0, negative 1/8. And now our directrix is supposed to be the opposite of our p-value. So what's the opposite of a negative 1/8? A positive 1/8. Okay, so we have our 3 main values. Now what we need to find is 2 other values for x and y. So since we're looking at some really small values, like an 1/8, I'm going to go ahead and pick a 1 and a negative 1. Plugging those into our equation to solve, we're going to end up with, let me go ahead, real quick, sorry. You're plugging it into here to solve, so plugging in x squared. And then we'll end up with y is going to equal a negative 2, and x is going to equal a negative 2 again. And once again, I'm assuming these are sort of Math 103 skills, or Math 135. If you ever have trouble figuring out how I found those values, just send me an email, and I'll go ahead and explain that further. Okay, so we found those 2 values, and we have found all 5 items that we need for a parabola. These are the 5-star items. Let's go ahead and graph. The biggest number I have on this graph is y is to negative 2. So right there, and then the x values go to 1 and negative 1, basically. So it's not really a large graph, or at least the numbers don't go that large. So let's go ahead and fill in our values. Vertex at 0, 0. Ooh, my question here, does our parabola open up or down? The answer is the parabola opens down. How did I know that? Well, my p-value was a negative, which means my parabola opens downwards. Okay, so let's go ahead and keep working with this. So we have our focus of 0, negative 1/8. That's really small, but let's go ahead and put that right here. F 0, negative 1/8. Doesn't have to be exact, but oh, I just realized I put my vertex right in between it. Okay, and then my directrix, we have y equals positive 1/8. It's gonna go smack through my vertex. Okay, or not through my vertex. It's through the label for my vertex. Okay, and there we have my directrix, my focus listed in. Next thing to do is to put in my 2 other points. So negative 1, negative 2. And then 1, 2. Or 1, negative 2. And there we go. Once again, make sure there's a nice curve to it. And there we have the graph of our parabola. Okay, so moving along. Alright, now we're looking at something a little different. This is a parabola with a horizontal axis. So before, if you'll notice, our axis, or our parabolas, were always opening up or down, and that was a parabola with a vertical axis. So now we're taking a look at something for the parabola with a horizontal axis. So it's going to be opening to the left or to the right. Now the graph of this equation, it's basically exactly the same as before. The main difference, our y is being squared and our x is to the first power. Previously, we were working with x squared equals 4py. And that's how we knew it was opening up or down. So now, since the y is squared and the x is to the first power, we're looking at a parabola that opens either right or left. That was switched. Right or left. Okay, so that's what we're looking at now. But it basically follows a similar idea. So, once again, we'll have a vertex and a focus. But this time, the way we write the focus and the directrix is a little different. For the focus, our p-value is first, and we have f of p, comma 0. But the way we find p is exactly the same as before. And then our directrix, instead of y equals, it's going to be x equals the opposite of p. So once again, though, it is still the opposite of whatever the p-value is. And the p comes from 4 times our x. And once again, the parabola opens, or not once again, sorry. The parabola opens to the right if p is greater than 0, or positive, so it opens to the right. And the parabola opens to the left is p if less than 0. So if it's less than 0, it opens to the left. Now let's take a look at example 3. Find the focus and directrix of the parabola 4x plus 2y squared equals 0, and sketch the graph. First thing to ask myself, is this a parabola opening up and down? Or is this a parabola opening left and then right? Which one is it? Should I take a guess? Well, how would we know? I mean, what are we looking for? On the exam, more than likely I'm not going to tell you upright. So how would you know? We're going to look at the value that's being squared. So notice, take a good look at this. The x is to the first power and the y is being squared. Alright, so I know this is going to be the parabola. It opens left or right because their y value is squared. Now the generic equation for that parabola is 4px. At the moment, my equation is not in that format. So I need to manipulate my equation into the correct form. So let's go ahead and do that. To do that, I'm going to have to go ahead and solve for y, so subtracting 4x from both sides. So 2y squared equals negative 4x. Y is still not by itself, so I got to go ahead and keep solving, so dividing by 2. And then we get y squared equals... Okay, so we could full on solve here, but I'm actually going to pause. I can rewrite this as 4 times negative 1 times a half x. And then I can rewrite that a little bit more, and that'll be 4 times a negative half x. Why did I do that? Well, if you recall, the way to find p is always to find 4 times some number, and that number is your p-value. So because I already saw that 4 there, I decided to leave the 4 by itself and manipulate my equation to get my p-value right there. If you didn't do that, that's okay. As usual, you would just have to solve for p equal to whatever value was by your x. Alright, so with that we were able to find our p-value. Let's go ahead and write down our important information. Once again, what is the important information? Our vertex, which is 0, 0. Our focus, in this case, it's switched, okay? So your p-value should be written first because we're looking at a parabola opening left or right. So that's going to be negative half, 0. And then our directrix is a line, remember? But since we're looking at a parabola opening left or right, it's going to be x equals the opposite of our p-value, so that'll be a positive half. Next, we need some points for our graph. Just 2 points as usual. So let's see, if I pick x equal to negative 2, oh sorry, not x, let's go ahead. If I pick y equal to 2, I can go ahead and solve and I'll get x is negative 2. And then if I pick y equal to negative 2, I can get x is still going to be a negative 2. Once again, if you'll notice, the way I pick values is I usually pick a positive and a negative of the exact same number for parabolas. Alright, let's go ahead and graph this. Vertex, 0, 0. Focus. So once again, if you'll notice, I'm doing focus and directrix in different colors because they're not actually on my graph. They're sort of a way of looking at our graph. They're a part of it, but they're not specifically on the graph. Okay, we're looking at half values in 2. So I'm going to go ahead and let's call this 1 and 2. Wrong color. Negative 1. Let me change that to black. Negative 1 and negative 2. And then 1 and 1. Okay. So my f is going to be negative half 0. Right there. So negative half 0. Let's my f, and then my directrix, d, is going to be x equals to positive half. So that'll be right here. Once again, smack through my vertex labeling. Label my line. And then lastly, let's go ahead and graph our parabola. This should be opening to the right or left? It's going to be the left. Why? Because my p-value is less than 0, so opens left. Okay, and then we have negative 2, 2, oh shoot, that's down here. And then negative 2, positive 2. A little off the graph, but fear not, we have figured out a way. Okay, and negative 2, 2. And then let's go ahead and draw in our graph. Once again, it should have a nice curve to it. Doesn't need to be perfect, but just make sure you include that it curves. And there we have it. We have our 5 points. We have our vertex, focus, directrix, and xy. Once again, sorry, this is not a point, it is a line. But we have our 5 main values. Now let's move on to something a little different. This is called finding the width. So the line segment with endpoints on the parabola and passing through the focus. So if we have a line segment that ends on the parabola, and what does it do? It passes through the focus, this little guy, is called the lattice rectum. The length of the lattice rectum is the absolute value of 4p and is called the focal diameter, where half the length is absolute value of 2p. And that makes sense because you're just taking half of 4p, which gives you the 2p. Alrighty, so let's take a look at this example. Find the focus, directrix, and focal diameter of the parabola x plus 8y squared equals 0, and sketch the graph. First off, what do we have here? Which value is being squared? So my y squared is the y squared value, and then I have my x. Okay, so that means because the y is squared, we're going to have a parabola opening left or right. Once again, the way it opens depends on our p-value. So let's go ahead and get this in the proper format. We need to get y squared by itself. So solving for y squared by itself, we'll get 8y squared equals negative x. Y squared is going to equal, well, if we divide both sides by 8, we will get negative 8x. Okay. It's a little harder to figure out what my p-value is here, so I'm going to go ahead and write finding p. Once again, I would not start immediately writing an equation right down here because it would look like it was an extension of this equation. So if you're ever trying to save space, but still using 2 different equations, just go ahead and use the little label to tell me, or whoever it is reading your work, that you've changed equations, which is why I wrote finding p. Okay, so finding p. Well, we know that 4p is supposed to equal that negative 8th. So to solve for p, go ahead, multiply both sides by a 4th. And what do we find out? Well, we find that p is going to equal negative 132. So 1 over 32. Okay, sweet. So that's my p-value. Let's go ahead and rewrite this. So y is going to equal, or y squared, equals 4 times 1 over the negative 32x. All right, there we have our equation in the proper format. So now my vertex is still going to be at 0, 0. What is my focus? It's going to be the negative 132, 0. My directrix, because we're looking at a parabola opening right or left, this will be x equals, and the opposite of negative 1 over 32 will be 132. Okay, so instead of picking our x and y value for the table, now we are looking at something. It's called the focal diameter. And these are actually points that are on our parabola. So instead of using the x and y table, we can just go ahead and find 2 points from our focal diameter to use for the graph instead. So what is our focal diameter? Well, the focal diameter, let me go ahead and write this down, focal diameter. That's supposed to be the absolute value of 4 times p. Well, the absolute value of 4 times p, this is 4 times p right there. It'll be 4 times the 1 over negative 32. So that is going to equal the absolute value of negative 1/8 which is an eighth. All right, so that is not actually our focal diameter yet. This is the latus rectum, this value here. So to figure out what our focal diameter it is half of that. So half of this, half of an eighth is a 16th. And then we would have our focal diameter points. So those points, let me go ahead and label them out, are going to be negative 132, negative 16, and positive 132. Oh, sorry, it's still negative 132. And then the positive 1/16. Okay, and then these 2 points are the points that will replace the other 2 that we were finding previously. So instead of using the table, we went ahead and used the focal diameter to find the 2 missing values that we would need. So let's go ahead and graph this. All right, let's use pink this time. Okay, so our vertex is at 0, 0. And then our focal diameter, or our focus, is at, I'll just call this negative 132, 0. It's my F value. And then my directrix is going to be at x equals 1 over 32. Should be the same distance away from our vertex. Let's label that x equals negative 1 over 32. Almost done. Oops, that should have been a V right there. V, okay. 2 more values to go. We're going to use our focal diameter for those other 2 points, so negative 132 and 1/16. Real quick, how did I know that this was the negative 132? Well, if you recall, the latus rectum, which the focal diameter is from, is supposed to be passing through this point. So we knew my x value was supposed to be that negative 1 over 32. Once again, that's where I got this from. Okay, so it's supposed to be there, and then my y value is the 1/16. Because these items are so small, I'm not really doing much labeling for this. So I'll just go ahead and plot these down as negative 132, positive 16th, and then the negative 132, negative 16th. And making sure there is a curve on my graph. And there we go. We have our lovely little parabola. So once again, if you're going to be using the focal diameter to find your 2 values for the x and y points, you don't need to use the table of values, okay? So depending on how you find this. If it doesn't state you need to use the focal diameter, feel free to use the table of values. However, if it does state to use the focal diameter, you do need to find that for those 2 values. All right, example 5. Find the focus, directrix, and the focal diameter on the parabola 10y plus x squared equals 0, and sketch the graph. Alrighty, once again, we need to decide which kind of a parabola this is. Let's look at our x and y variables. Well, the x is being squared, so this means we're going to have a parabola that's opening up or down. Alright, let's go ahead and get this in the right format to be able to find everything. So getting x squared by itself, that's going to be negative 10y. Okay, as usual, we know we need to find our p-value. So to find the p-value, we're going to go ahead and write finding p. So whatever this value is, we know we're going to set that equal to 4p and solve. Dividing both sides by 4, we will get that p is going to equal negative 10 divided by 4, which is going to be the same as negative 5 over 2. Okay, so that's my p-value. Let's go ahead and rewrite our equation in the right format. So that equals 4 times negative 5 over 2y. All right, let's go ahead and state our known values. So the vertex is going to be 0, 0. My focus is going to be at, let's see, this is opening up or down, so this should be 0. And then my p-value, so negative 5 over 2. And then my directrix is going to be, because it's opening up or down, it'll be y equals, and the opposite of our p-value, so 5 over 2, positive 5 over 2. Okay, those are my 3 main values. The next thing we need to find is the focal diameter. So instead of using the table of values to find my other points, instead we're going to be using the focal diameter. So let's go ahead and set that up. So focal diameter. Okay, so we're going to use the absolute value of 4p. The absolute value of 4p is going to equal, well, the absolute value of 4 times the negative 5 over 2. And simplifying that, we already kind of knew that was going to end up being 2 times the negative 5, which is going to be negative 10. And the absolute value of negative 10 is just 10. Now, real quick, that, once again, is the lattice rectum. And we need to find the focal diameter, which is half of that. So, focal diameter, so half of 10 is 5. So, our 2 points. Real quick here. Focal diameter, we're going to be using our focus value for part of the points. So we have the y value is negative 5 over 2. So I know that. Let's go ahead and fill this in. So I know my y value should be at negative 5 over 2 for both of these points. Because once again, this is all based on looking at passing through our focus. And then that means that my y values are going to be at a positive 5 and a negative 5. Sorry, those are my x values. So once again, this is a great way to show your work. And let's go ahead and box these two. And then also box your other important information right up here. You could always rewrite these points up there with them and just box one thing, but just as long as you box them. All right, let's go ahead and graph this. So vertex is at 0, 0. My focus is at 0, negative 5 over 2. And then let's see, my directrix is at y equals positive 5 over 2. Let's go ahead and, that's not the best looking line. There we go. Let me fix that. It should be as straight a line as possible. So if you have like a ruler or something when you're writing your test out, that would be awesome. All right, that's a little better. Okay, and then let's see. So for the 2 points that are actually on my graph, those come from when we found the focal diameter. So we have 5, negative 5 over 2, and negative 5, negative 5 over 2. All right, so let's go ahead and say that this is the negative 5 and this is 5. It's not perfectly scaled, but it doesn't need to be perfectly scaled. Oh, that should have been a little higher. It's supposed to be in line with the focus. That looks better. Okay, and there we go. With our arrowheads. Once again, arrowheads are part of the graph, so make sure you put those in. Then we get the 5, negative 5 over 2, and the, the negative 5 and the negative 5 over 2. So once again, let me just go ahead and point this out. These 2 points come from that item that is called the lattice rectum, and the focal diameter comes from half of that. So we get those 2 points from that. Alrighty, and that is it for section 11.1. Once again, if you have any questions on any of these examples or any of the homework, feel free to email me and set up an office hour.